Good morning, dear Form 4 students. Welcome to the class. We are still on our topic current electricity. We have done quite a lot as far as this topic is concerned, and we are getting to the end of this topic. We have done so many things such as calculations and the calculation of electric bills at home. I believe that at this time you can do a lot, you can do so many calculations, even though I've received only few work from you. Some students are trying their best, meanwhile others are still sleeping. I therefore urge you to do your work and send. Today we're going to look at the direct current and alternating current. And the next week we are going to see if we can go through the work. But today we are going to look just direct current and alternating current. A direct current flows only in one direction. A direct current flows only in one direction. For example, the current from a battery is a direct current. The current from a battery, it can be the battery of your watch, the battery of your calculator, the battery of your torch. The current flowing from that battery is a direct current. And the current time graph is a horizontal line. It's a horizontal line. You can see the current time graph on your screen. If you look, you have an horizontal line. This horizontal line shows that the current flowing is direct. If we move ahead, we're going to look at alternating current. Just from the word alternating, changing, alternating current. It means that it's a current that changes its direction with time. Alternating current is a current that changes its direction with time. A good example is electricity supplied by a new is alternating. It has a frequency of about 50 Hertz and an EMF. That is, EMF stands for electromotive force, an EMF of 220 volt to 240 volt. That is the frequency of a new, and that is the range of the voltage. That is from 220 volt to 240 volt. You can see the diagram of alternating current. You can see the peak. There is a peak. It means that it moves to the peak and it falls back to minimum. It reverses its direction at each time interval. Okay, we are going to look at the comparison of AC and the DC. We talk comparison. We're going to look at the differences between AC and DC. AC stands for alternating current and DC stands for direct current. We are equally going to look at the differences between AC and the DC. Okay, we start by looking at the similarities. They both cause a heating effect in a material through which they flow. It means that the material which AC and DC flows, they causes heating effect on these materials. And the next similarity here we have, they both set up a magnetic field around a conductor through which they flow. Therefore, a DC set up a magnetic field around a conductor. Equally, AC set up a magnetic field around a conductor through which they flow. These are the two similarities between AC and the DC. Okay, let's look at the advantages of AC over DC. In other words, the difference, where advantages is still the same as the difference between AC and DC. the advantage of AC over DC. Okay, let's look at the first advantage. AC can be stepped up and stepped down using transformers, while DC cannot. Therefore, the advantage of AC over DC is that AC can be stepped up at the same time stepped down using a transformer, but DC cannot be stepped up or stepped down. There's the advantage of AC over this. At the same time, you have the difference between AC and the DC. The next we have AC is cheaper to generate than DC. It's very easy to generate AC compared to DC. You have the third point, you have AC is cheaper to transmit with the help of transformer. AC is cheaper to transmit with the help of transformer. These are the advantages of AC over DC. At the same time, there are the differences between AC and DC. Okay, let's move on. We look at the advantages of DC over AC. Remember, AC has an advantage over DC. Equally, DC has an advantage over AC. Let's look at the advantages of DC over AC. The first, we have DC is used in electroplating, while AC cannot. You have done electroplating in chemistry. Electroplating is a coating of the surface, of a metal to make it smooth and shining. The coating of the surface of a metal to make it smooth and shiny. For example, your spoon, the eating spoon in the house. The eating spoon is shining, or you can talk of any shining object like a silver, like a stainless steel. All these materials are coated to make them shining. It's through a process known as electroplating. And therefore, this electroplating can only work with the supply of DC. We take the next advantage of DC over AC. Here we have some appliances and electronic devices requires only DC for functioning. For example, we have the radio, amplifier, etc. These are some devices that requires only DC for functioning. Here you can see another advantage of DC over AC. Okay, let's see, how can you convert, ask yourself, how can you convert AC to DC? How can you convert AC into DC? There is a device that we can use to convert AC into DC, and this device is known as a diode or rectifier. We use diodes to convert AC to DC. The diode allows current to flow through it in one direction only. And therefore, when current is alternating, once it comes across a diode, the diode would permit the current to flow only in one direction. Therefore, we call a diode a rectifier. The process of converting AC to DC is called rectification. I repeat myself again. The process of converting AC to DC is called rectification. Remember, it is impossible to convert DC to AC. It's impossible to convert DC to AC, but we can convert AC to DC.